Hi, welcome back. Let's build that cluster using those Dell Wyse terminals and see how far we get. Here's the massive wires that I've connected up. There's currently, 5 power supplies. So there's 4 Wyse terminals. I've got a rig up, and there's also a power adapter for the gigabit switch. And it's all on this particular power switch here. So I can flick that and have the whole cluster come on. This is a temporary measure. I've got some ideas on how I can make that nicer. At the moment I've only got 4 power supplies, so I can only have 1 control node and 3 nodes in the cluster. Let me show you that. This is what it's going to end up looking like. So we'll get rid of node 4 because we can't service that right now. These are all of the power leads coming back. So let's start plugging it in. So that's the control node. Oh yeah. So I've got hold of some network cables. I've got a pack of them here. I was going to make up some cables, but I actually ran out, would you believe, of lead. And these are quite nice because these are flat cables, so that might actually look a bit nicer and be easier to route and that sort of stuff. That's the plan anyway, so let's install that. Right, let's turn him on. So those will power on initially and then shut down. So they're now waiting. So if I turn all of these on, oops. Oh, that one node 3. That'll be node 3. Four little Linux machines all ready to rock with a separate switch. So let's go and see what that looks like from a networking point of view. We'll have a look at the networking. I'm using my Linksys app because all those nodes are DHCP. So I can hopefully go in there, identify these nodes. Right, so that's one of the units. So it has this loop back there. It won't know about the other nodes. Oh, it does know about the other nodes. Okay, so that's node 2, node 3, the other one's called CTRL, which is 69. Now I need to find these and reserve these here because they seem to have disappeared out of my list, which is very annoying. I'm going to configure Llama, distributed Llama on these nodes. So I'm just going to quickly power it on, and I've got 4 terminals here. So this is the control plane. That's node 1, node 2. These are IP addresses, a bit random, but so let's log in. Just take a second for these machines to wake up a little bit. Okay, and that one, and that one. Okay. Okay, so we're logged into each of those. So now we're going to super user it, and there was this command here, which is spawning a Llama worker thread, worker process with 3 threads. It doesn't work with 4, basically. Oh, hang on, I've got to go to the distributed directory and do that. Okay, so we're going to go to the distributed directory. Oh, we're going to go to I think it's in models itself. Actually, you know what? I'm not going to bother with any of that stuff. So you can run this in chat mode, in API mode. You can inject a query. just get data directly. But here, what we're going to do is put it in chat mode. So it's a text chat in the console. It's going to use this language model, and it's going to add these worker nodes in. Okay, so these are all just listening. There's no authentication and that sort of stuff. It's just straight in. So this is the control node. This is talking to the 3 worker nodes, and obviously I can add more. Now it's going to load the large language model files, about 4 gig. So we're not going to have a specific prompt, we're just going to go straight there. So now it's in an interactive prompt mode. So what is the wavelength of infrared light? Let's ask it a science-based question. So now it's off and it's flashing away, talking to the 3 nodes that it has, trying to come up with an answer. So it is distributing the request. It is very slow, as you can see. It is super slow, but it does work. I mean, it proves that it does work. What's interesting is I'm going to do some comparisons and see what it's like adding another node, removing all the nodes, having 1 node, whatever. It is no speed demon, but it's a cluster, an LLM cluster, and it does work. You know, it's quite cool. So this repo here is amazing. It's amazing stuff. One thing I haven't managed to get to work yet is the API mode of it, where you actually bind this console effectively to run as an API. I can hit that API endpoint and that works. But you're supposed to be able to go here and add the where is it? Yeah, settings. Add the URL to your local server. This is essentially it's an application running on your local machine. Essentially, it's a web browser, but it's running commands locally. So it's pointing at this base URL, and you're supposed to then be able to chat in this, and it actually has speech recognition and speech synthesis, which is really cool. I'd love to be able to play around with that, so you can actually talk to the thing and get answers out, because this looks really slow, and it is very slow. But interestingly, if you're having a conversation, it may not be quite as bad. But there you go. I don't know. It is painfully slow. So yeah, so there we have it. Well, electronic brain, I guess. So what we're going to ask it? Do you like the website? You like the website rotogingers.com. I'm not sure whether it'll be able to. It's allowed to connect externally, or I mean, you wouldn't know anything about that. Why would it? This is a bit of a hedge. I don't have personal preferences or opinions. Oh, it can provide information about rotogingers.com. It says it's a website that appears to be a fan site dedicated to retro video games. Okay, so it's gone out to the internet to actually look at my site and figure out what it is. Apparently, it's focusing on the NES. Oh, not sure it does. Well, there you go. There's a review of the site. So, you know, obviously I'd recommend it, but hey, I'm slightly biased. My Llama here, I'm not sure. Yeah, I take that with a pinch of salt. Is there any NES stuff on there? There might be one thing about NES. I don't know. I don't remember. Okay, anyway, so you get the idea. It kind of works. Is it any good as a cluster? Probably not. Is it going to be faster than the Raspberry Pi? Definitely not. That's heavily optimized. There's probably ways I can tweak this to make it faster. Has it been fun? Yeah, it's been really good fun, and I like the fact that those machines basically were a tenner each. It's so cheap. So here's a test with 1 node. We're going to time the same question, and then we're going to add a second node, and then all 3 nodes, so we can have a look and see the difference in performance. Right then, so we are at the prompt now, so let's ask pretty much the same question. What is the wavelength of infrared light? So we're going to add a timer. So let's start that running and start that running. So this will get a bit meta. I had to go back over it. So that's 6 minutes 43 seconds for just the control node. Let's add another node in and test it again. Okay. Here's the wave. Okay. So the first one was 6 minutes 43. This is 3 minutes 45. So almost halved it, which is pretty impressive. Let's quit that. Let's bring in node. What is that? 222. Right. So here's a 2 minutes. So here's the final tally. So you see, as you add more nodes, things get significantly faster. So that's good. It's good to know. Kind of obvious in some ways, but it's nice to know that actually the cluster is doing something. It's not just there flashing lights. Even though they're very low power units, you can add more of them in there to speed things up. So you can see the benefit of that cluster. Obviously, there's bottlenecks because it's only a gigabit switch. There's 8 gig of memory per unit, so that's another bottleneck. Really, you should have more memory in the control node, but hey. So yeah, it is what it is. I think it's quite cool. It's nice to see that comparison.